No, your computer is not broken, and my mouth is moving, so words are coming out of my mouth. We're just giving everyone about another 20, 30 seconds, and we'll get rolling. If you have questions, we'll entertain all the questions at the end. And 10, 9, 8, it's going to be a launch. So about 5, 4, 3, 2, 1. Welcome, everyone. My name is Truglia. I'll be the instructor today. Welcome to the AutoLeap family. I use AutoLeap in my shop for real. Look at that. So I'm going to give you some good information here as a shop owner, what you kind of need to know. And let's go through that since we don't have a lot of time. There's some of my info there. Going on my 50th year. We're going to cover in a New York minute hybrids and EVs, information about them, what you need to kind of know in your shop, safety, tools and equipment, and all of these vehicles from the Honda Insight that we just finished fixing one the other day, all the way up to electric vehicles like a Tesla and many other cars that are out there. So electric vehicles on the road, Nissan Leaf, one of the first ones out there, full electric, Model S Tesla, and you got Models X, you got Y, you got the 3, and many more to come. The BMW i3 and more of those to come, as well as other manufacturers. And we have the Chevy Bolt, and GM has the Hummer. They're coming out with a Chevy pickup truck. They have the Cadillac. There's going to be a whole bunch of these things. Whether you like them or not, doesn't matter. They will be on the road, and it is an opportunity for you to cash in on, okay? So the difference between a hybrid, I want to get this out of the way. If you're working on a hybrid, why don't you type a little Y in there, and he'll let me know how many of you are, okay? The difference between a hybrid and a full EV is only it does not have an ICE, internal combustion engine. An ICE within a hybrid vehicle has two forms of propulsion. It has a gas motor, and obviously it has electricity to move it. In an EV, all you have is the electricity to move it. So we'll go through some of this stuff here. So high voltage, this is what you got to be aware of if you're a shop owner, even if you're a tech when working up in Alaska. That bad bit, the big one, and it's dead as a doornail. My buddy's hand here, Alberto De La Rosa, he used to be a BMW mechanic. He did not get hurt working on a high voltage vehicle, but rather when he went into the construction business, he went into a 408 volt panel, knocked him clear across the room. This guy was in phenomenal shape, took him over a month and a half to get his heart rhythm back. And look at his hand, which did get back to somewhat normal. Now, here's what manufacturers have to say. High voltage, you'll be killed or hurt. Do not remove this cover. I've removed many of these covers. I've reconditioned many, many batteries out there. If you know what you're doing, you're not going to have a problem. And we're going to talk about what you need in your shop for liability purposes and to protect yourself. PPE, personal protection equipment. Now, every day, this is outside my building. There's a big transformer right there up on a pole. And here, you see this? This is our underground wiring coming into my building. So all of this here, it tells you they can be killed or hurt. When was the last time that you heard a utility worker be killed or hurt? Pretty unusual, okay? Now, when a storm happens and people throw generators on that shouldn't be on, they have no cutoffs, things happen or wires go moving around. But I know many high voltage utility workers and nothing happens to them. I've done stuff for our utilities in New York City and upstate New York. So hybrid safety, just like a flashlight, there could be power in these cables at any time. You need to make sure the vehicle is off. A little later on in the presentation, I'm going to show you what the Europeans do to make sure that they will even allow you to work on an electric vehicle. And we'll talk a little bit more about that later. You need some shock blocks. Many of these electric vehicles or hybrid electric vehicles, they are basically silent. People have a tendency to get out of that vehicle when the vehicle is still on. They don't know that they have it in gear. Why? It's totally silent. This is a big issue out there. Now, as a shop owner, as a technician, you need PPE. So you're going to need the bag, We don't have it here showing you glove dust, the special covers, the class 0, 1000 volt gloves, all to be put on and only to be used by that person. You do not share your rubbers. You wouldn't do that, would you? Sharing rubbers is not something you want to do. A rescue hook. You need this in your shop. If you don't have a rescue hook, I never do the class without one. When the Marines had me go to Okinawa, Japan to teach them hybrid stuff, they said, "Oh, can you bring that pole?" I go, "I can't bring that on a plane. What are you, crazy?" Okay. It took over $250 to ship it from New Jersey. I would have drove there if I knew that in the beginning. Now the poles come in pieces that you could do that. So the Marines had to go buy their own in Japan. Now let's talk about the components that your techs, or if you are a tech, need to be familiar with. Everything starts with a DC high voltage battery, nickel metal hydride or lithium ion and lithium polymers coming down the road. Then it goes to either a single motor generator or a dual motor generator, okay, depending what type of vehicle it's on. And we're going to talk about that a little bit. And then it goes into this thing here, an inverter. And underneath that on this particular Toyota setup is a converter, okay? Now, you got something, IGBTs, insulated gate bipolar transistors. They are very, very important, and we'll talk about that as we go through. So an important fact to know here, what does an inverter do? It converts the high voltage DC current to three-phase AC current for the motor generators and regen. AC is converted to DC to charge the high voltage battery. That is called regen. It boosts the DC voltage from a lower voltage, like in the case of this Prius, 201 volts is what the battery is, but the motor needs 500 to 600 volts. So how are you going to do that? Well, you're going to see what's inside of these things. They're called capacitors. We need to boost that voltage up to get this vehicle moving. What does a converter do? Well, it takes that high voltage DC, and of course, you have a regular OBD2 system. You have regular light bulbs on the car. You got a regular 12-volt system in the car, okay? The converter acts also as the alternator because there's no alternator on this car, okay? The converter has to take that high voltage, lower it to charge the 12-volt battery, or in some Teslas now, a 15-volt battery, okay, in order to run all of the non-high voltage essential electronics on the vehicle, okay? This is called a megometer. You're going to need one of these in your shop. So a mega, the lights wouldn't be on in this building if an electrician didn't do that, and let's say a carpenter putting a ceiling up or a wall up, he shot a screw into the wire, well, they could have an issue, right? If you put your megometer on it, they could tell if a wire was shorted or a wire is good enough to go. So that's what this does here. Because of the amount of time, obviously, we don't have a lot of time to dwell on each subject. Please write your questions down and we'll take them at the end. So this is a megometer. And basically, it's like doing since voltage is pressure, amperage is flow, it is basically like pressure testing a pipe. What you're going to do is read the specs, RTFI, read the frickin' information. Very, very important, because you don't want to take a wild ass guess and be on 1,000 volts when maybe they only want 500 volts or 250 volts, okay? You need to know how to use the meter and what voltage to apply. So service information, all data, pro demand, Identifix, and Motologic, all super, super important to make sure we have the right testing. Milliometer. Now, a milliometer can read very low ohm readings to the motor generator, okay? So the motor generator, sometimes Toyota had this problem. They're the only ones that are actually using this, okay? They want to see if they have some sort of a problem. And as you can see here, only use that Toyota at this time to measure very low resistance, less than 1 ohm. The megometer cannot do that. So when I do hands-on class, I show them the difference between looking at a megometer and looking at a milliometer and when to use it and how to use it. Let's look at batteries real quick. One of the things you don't want to, if you're in the body shop business as well, one of the things you don't want to do is overheat this battery. You can see it says here the 144 volt battery. This is a Honda. Okay. It does not like exceeding 150 degrees Fahrenheit. When you're in Phoenix, Arizona in the summer and it's 118, 120 degrees, how hot is it in your vehicle when the windows are closed? A lot hotter. You could add 40, 50 plus degrees. And if you move from the north or something and you have black interior, let's get the holy water out to bless you, because it's going to be brutally hot inside that vehicle and the batteries do not last as long. Also, they do not like extreme cold weather as well. Okay. Now here we have another thing, what to do with disposing of a battery. We do not want to throw these things in landfill. We do not want to just chuck them in your backyard or whatever. These all need to be recycled properly. Okay. So each battery has a number on it to where you can call, or each manufacturer will give you a number to call. Usually it's the same recycler, but you need to give them a buzz. Okay. There's different types of batteries. The cylindrical cell battery could be mounted any way. This was used by Honda and Ford, smaller versions of it. And now Tesla's going to this big version of it. This is like a D-size cell battery. Some are like AA batteries. Some are a little bigger than AA batteries. Some of them are prismatic batteries like this that cannot be mounted any different way, but basically mounted in a horizontal position with vertical facing up so no liquid can actually come out. Now they tell you there's no liquid in it, but the battery cannot be mounted other than horizontally, okay? And each one of these little pieces here, you see those, and they got a little line in between, like right there? That's 1.2 volts each. This is 7.2 volts per prismatic sub-pack. 2 sub-packs make a pack. That's why if you look at a scan tool later, you're going to see over 14.5 volts, okay? These are laser welded together in a pack equaling 7.2 volts each, for a total of 6 of them, 1.2 volts each, and that will add up, okay? They both can put out way over 100 amps, and remember, current can kill you, right? Now, this is a Chevy Volt battery here. A Chevy Volt is, the battery itself weighs about 600 pounds with the coolant, the cover, and everything. It's a 360 plus volts on this battery. You can see how it is a T-type shape. Very, very good battery setup there. By the way, over $20,000 for that battery, okay? And you need a special fixture. Now, these are things that become serviceable. Here, the Nissan Leaf pouch batteries here. You can see the pouch batteries here. They have 2 in series, 2 in parallel, and the battery is under the vehicle. And here's the Tesla battery. Tesla first used the 18650 cell, and then they switched over to the newer cell in 2017, the 2170, and now they're going to a D-size shaped battery as well. And all of these battery packs for full EVs are 360 volts and up, usually near the 400 and something volt range. Okay. Now, these are special fuses. For example, here, this fuse, you'll notice it says SOC FT 235, DC 500 volts, 100 amps, IR 2000A. IR, initial rush, 2000 amps. You know, when you first crank a starter motor over, you need that extra. If you looked at it on a lab scope, you notice, whoa, that 4-banger pulled 420 amps. Yes, it did. Okay. But you know, you can't do that for a long period of time. It could do it in milliseconds. 1,000 milliseconds make 1 second. So it does it very quick in a couple of milliseconds where nothing is going to burn up. But we always use more current first when we start moving it. This, if you took an ohmmeter, you see this here, this fuse, by the way, you're looking at an $855 fuse. This right here, if you put your ohmmeter across, you get a reading. Put across here, you get a reading. This happens to be bad. It won't start the vehicle up, making it ready. This will start the vehicle up. Safety interlocks. Now, having been one of the people that wrote the ASE L3 test, I can tell you a lot of the stuff I'm showing you, including coming up SMRs, system main relays, system interlocks are for safety reasons. This is a 5-volt circuit here. And when you lift this inverter cover, see that gasket, very small, you have to sell to your customers any leak that's on that car. I don't care if it's an antifreeze leak, an oil leak, if it's a hybrid, anything that's leaking near the vehicle is going to cause a problem in the electronics. Because inside that inverter is IGBTs, the insulated gate bipolar transistor, okay? That is in there that converts the DC to AC and the AC to DC. No, it's not the group AC DC. Nope, not at all, okay? But these interlocks are an extra level of safety in case someone lifts that cover, okay? And all this stuff needs to be worked on with Cat 3 leads, meters, and until you could confirm that the vehicle is powered down, well, you're going to need to keep your high voltage gloves on there. SMRs, and this courtesy of Toyota Motor Company, just to give you a better depiction here, I have pictures as well. You got 3 SMRs, system main relay. You got 1 pre-charge relay. You got 1 positive relay and 1 negative relay. The reason for these things, if I put something on and I have a high current flow going through, like this does, okay, what would happen to the relay? They would stick together, right? It would be like a bad condenser in the old days of points and condenser. When a condenser got weak and couldn't quench the spark, they welded together. Or like a Ford fuel pump relay where you got to go, you got to give it a good bang because the relay contacts stick. You don't want this to stick on a high voltage vehicle, so they use resistance in series called a pre-charge relay, and these are called SMRs, system main relay, something to really understand. Motors, if you're used to working on an alternator, when I got in this business, well, alternators were the things that you would rebuild. And when you rebuilt them, well, you knew you had to put new brushes in. It had a stator, it had a rotor, and you had to check it. That's 3 phases of electricity, UVW, okay? Well, the high voltage motor, whether it be a hybrid or an EV, is going to have everything similar except brushes. There are no brushes. These are 100% brushless motors. It's a Hall effect inductive sensor, small magnets attached to the rotor shaft, output triggers the device electronically. So you're going in a counterclockwise direction, UVW, spinning that electric motor over at 1,000+ RPM. Now, here is the actual picture. When I do hands-on classes or work on the cars, I show this how you need, with the proper equipment. This is an ATS E-scope with special leads. You cannot use those leads. You cannot use a Pico scope. You cannot use a snap-on scope. You can use a fluke scope or any scope that is Cat 3 certified. If not, someone can get hurt or you could damage the unit, okay? So here are the 3 phases of electricity, and notice the signature. You see there's like these little bell humps, and notice how they're all good? This lab scope has 2 different time frames. You may not see one of these drop out, but if we had a problem here, we would see a hole in it. In the sake of saving time, I took the video out that I would normally show here just because it takes a little too long. Here is the IGBT, okay? The IGBT took this AC signal and made it a modified DC signal. There is nothing wrong with this signal. You think, oh no, gee, it's missing red over here. Oh God, it's all over the place. That's not how it works. This is why you need to build a WAV file program. OEs don't even have this information. So Honda's not going to put that out there. Toyota's not going to put that out there. Tesla's not going to put that out there. They all use the same type of stuff. When you want to see a hole in a picket fence, you look for that little hole right there. You won't see it because of the time that it's coming through on your scope. So this scope has 2 time bases where we can see here. It's wide enough, and this is called the signature of the signal. If we had a problem here, a hole in it, we would see it right away. Some of the shutoff or disconnect switches, all of these need high voltage gloves. This does not need a glove. The new ones here do not need a glove. This BMW i3, the first year is orange. That's wrong. That's not high voltage. That is a low voltage disconnect. Okay. And wires that run under this vehicle, like if something happened to this exhaust, there's nothing covering this. This is right from the factory. At this time, this was relatively a new vehicle. Okay. You can see something here on the Major Deacon, right near the great Yankee Stadium, I must say. Okay. Well, what happened there is something came up. It hit not only the exhaust system, but it ruined the wire. And at that time, I think it took 6 months to get the cable from the front to the back, because you cannot fix these cables. This is not like overhead wires where maybe a bird just sits on it and no one's going to get hurt. This is under the vehicle and we could have a problem. We got copper wire, we got insulation, we got shielding, and we got more insulation and a ground. Okay. So that's the difference here. Regenerative braking, you can see how those rotors rust up. In fact, on one of my hybrid vehicles is 280,000 miles with the original brake pads on it. Okay. You have to service the brakes, meaning you're going to have to lubricate the calipers. You're going to have to take a DA and clean that rotor up, because rust will build up on it. Regen is using the electric motor to put the voltage, AC voltage, into the inverter, changing it in the inverter through the IGBT, the insulated gate bipolar transistor, making it DC to go back to the battery. Okay, that's how it works. Now, EV vehicles, they have everything the same, except there's no ICE. And an ICE is an internal combustion engine. So you still got the high voltage battery pack. Most of these, I don't know anyone using an EV with nickel metal batteries, but who knows, there may be someone out there. Everyone else uses lithium. You're going to have a motor generator. You're going to have an inverter and a converter and an electric air conditioner. Now, I've been in business many years, and, you know, we were speaking to Will before. He's down there in Atlanta. It's 80 degrees, probably the humidity's building. It's crazy weather, right? Well, you, as a shop owner or a tech, people are going to need to come in and have their air condition serviced properly. If the air condition ain't working right, that battery will not work right. You may shorten the life of that $30,000+ battery. These batteries on EVs, rather than $20,000 or $15,000, they're up to $30,000+ or more. Okay. NASTF, National Automotive Task Force. What you need is, a lot of these vehicles need to be programmed or reprogrammed, or you're going to need the factory scan tool. And if you have a J2534, like an Opus tool or a DrewTech device, which is the same exact tool, well, then you can go in there and use that hardware to make your computer talk with the factory info to the car. And you're going to need that on a lot of these vehicles. Okay. A Honda Insight was a 3-cylinder car, used an electric motor. And you may go, no one uses that junk anymore. This is called an IMA, Integrated Motor Assist. It is one electric motor. Okay. It is bolted. This is a parallel type system. Okay. And it is bolted right to the engine. So what you have is, every time the pistons go up and down, the rotor rotates. The stator is bolted to the block. The pistons never stop going up and down. So what cars have this? Oh, Ford Motor Company. They started using this. They went away from a 2-motor system. Oh, you know those guys at Toyota that were going to do full electric? Well, Mr. Toyota said, we don't think full electric's going to fly. We're going to stay a bit longer with hybrids. And what they did, they developed a 2-motor generator. They went back now to a 1-motor. The new Tacomas and their other pickups are going to have 1-motor generator, and it's going to look just like we're going to show you in a little bit here. And that is a 1-motor generator, also used by Hyundai, BMW. Okay, that 1-motor generator right there, this one is wound. We have not seen one of these fail. New York City used to have a lot of these cars. All the vehicles that I worked on, or the mechanics down there worked on, we haven't seen one of those motors go bad. We have seen their batteries go bad, okay? But in my state, we're 10 years, 150,000 miles. That is in 13 or so emission states, California included, New Jersey as well. So if your state is not on one of those 13s, Oregon out there, you would have Washington State, Maryland, and quite a few others. Here on this Honda, you can see we're testing, but we do have a guy that's not paying attention here. Two guys that are not paying attention. They got rubber gloves, but no covers. These are regular rubber gloves that if you're not careful and you get one little pinhole, it could be a shocking experience, and the last one at that, right? We don't want to do things that are wrong. This is poor PPE. When I took this picture, I can't say where, I don't want to get anyone in trouble. These guys had covers, but didn't use them. Go figure. So I said, okay, you're not dead yet, stay there so I could take the picture, right? And here are three 450 volt capacitors. Capacitors are different than a battery. A battery chemically makes electricity, stores electricity, okay? A capacitor only stores electricity, and there's a big charge in there, 450 volts times 3, quite a bit of a shock. Here's a battery that we had out. We're going over. Now, they call them MCMs, but most of everyone does what Toyota says SMRs. These are the contactors. Here's the pre-charge resistor. Here are a couple of fuses. Here's a current sensor, always on the negative side. Even with the battery turned off, right there where that little red thing is, this battery still will have over 60 volts on each side. So if you're poking your fingers around here, you better know what you're doing, because if you hit the wrong thing, DC does not push you away. This was one thing, the greatest man, he was a great inventor, Thomas Edison. Here's where he was wrong. He lit up Lower Manhattan in DC, and Nikola Tesla, who used to work for him, went to go work for George Westinghouse, and Tesla was correct. AC, you've all probably plugged something in the wall, got a shock. You've been, shocked, but you're still alive, right? Have you ever been to a chiropractor where they put a stim machine on you? Sure you have, right? And then if you overcrank, you're like, ah! Well, you'd be dead. You wouldn't get the ah out of your mouth if you get hit with DC voltage. So you need to be good with that PPE. Programming. So right here, this was OTC. This was the same unit made for Honda Motor Company. Now, the newer one does not use this particular hardware. We no longer use this. We use the newer Honda stuff, which is a DrewTech device. Notice on the door, it will tell you what battery type, PC1. You can see here, it'll tell you the IMA software, and here are some of the other batteries. Sometimes you got to put CA4, CA1, or YSH, no label. The reason why you got to do that, if you replace that battery and did not do that, that battery will not have proper life and the vehicle will not get the proper mileage per gallon. Electric air conditioning. Here on a Honda, notice there's a belt back here. Oh, Mr. Honda was very, very smart, and he knew if you were running the gas engine, why waste the battery electricity? Let's run it there. When we're running electric, we'll run the electric motor here for the AC, and we have an AC controller that does that. You cannot use any PAG. Now, for all that you guys have out there, your air conditioning machines, I don't care, you got hose flush. You could take that and flush it, okay? That is not going to help you if there was any PAG oil in that system. PAG oil in that system is going to be an issue. One drop, not because I say it, manufacturer says this, okay? MAC says this, the Mobile Air Conditioning Society, or Climate, whatever the new name is, but it's still called MAX. One drop of PAG oil can actually ruin that vehicle. Some vehicles could be shut down with something called an isolation fault, or minimal, the whole air conditioner will be shut down, and every single component in the system, hoses, lines, evaporator, condenser, accumulators if it had it, you name it, receiver dryer, all have to be replaced, a very expensive proposition. Here we're using the Honda software, and we can see our voltages all over the place. What did I say those batteries were? 1.2 volt, and 6 of them in a stick, 7.2 volts. That is a sub pack, 2 of them. should take about 14, 15 volts. There's one good one. Look at the rest of them. We got one here down to 8.5. And to show you, I took a thermal imager. We have a special machine that reconditions batteries, and we could tell if something is bad. A thermal imager is a great tool. You got to invest a little money like you invested in everything else. Some people are investing in ADAS. What a great thing, because so many cars have ADAS on it. Well, same thing here. If you're going to work with hybrid and electric vehicles, guess what? You better have the right equipment, right? There's that electric compressor here. And it tells you here is the warning in SE10 oil only. And look what it says, shock and death warning. So do you know how to actually connect, or should you connect to a vehicle that actually is an electrified compressor or has an electrified compressor? Okay. Let's look at some stuff here. The older Prius didn't have a fuse in it, was on the battery. Always wait 5 to 10 minutes before depowering. And here we have a problem, 2001 to 2003 Priuses. If you left the car in neutral or park with the key on, guess what? The battery went dead. When this happened, there were only 5 chargers in the whole United States that Toyota reps would come around and try to get these things started. Now, every Toyota Lexus dealer has a charger. There's no backup starter motor on this, like some of the GMs or some of the Honda vehicles. Here, they had a recall for a battery campaign. Always look at TSBs, technical service bulletins. Inside the Gen 1 converter, you see these caps right here? There's nothing that cover them. You see this cover? If this car goes under a vehicle, let's say under the back of a tractor trailer, you hit the metal part to those terminals, you're going to hear like a huge explosion, okay? Like about 20 M80s going off at once, if not worse than that, okay? So that's where we store stuff. We have a resistor on the block here that'll bring down the voltage. Here, we're testing the microfarads of the capacitor to make sure the capacitor is in specification at a certain temperature. And here is a problem vehicle. Let me take a sip here. I'm running dry. Here is a vehicle that came in, not sure how this thing even made it here. Look at the battery blocks. They're all over. They should be 14 or better. Look at this, 4 volts, 3 volts, 5 volts. Here was one of the problems. This had ready to go on. You saw that white stuff on the bottom? That was ready for an isolation fault. By the way, you see how these terminals look all funky here, and you see some brown stuff? You remember that recall? The recall was the battery was leaking. They took a glue gun right from the dealership. That was the factory fix. They had to clean the bus bars up. There's a clean bus bar. Look at these dirty bus bars. That is VD, voltage drop. Okay, not what you were thinking. VD, voltage drop. We have any voltage drop, that battery cannot put its full power out, nor could it take a charge back in properly. So that would be regen. We use Stable in 22A, CE1 from Napa, SL5, CarQuest or Advance. That is some special stuff. You only put a small amount of it on a Q-tip, and it only goes on one side of the circuit. And there is the difference with the bus bar is dirty and an example of a bus bar clean. By the way, you cannot sand them. You cannot use emery cloth or anything like that on them. Oh, I just happen to have some here in my, you see these? Okay, probably got to do one of these. So you can see how bad these are, and you can see like right in there, that is going to give you a major problem, okay? Just happen to have them on my desk, I think, from the last class I did. So very, very important. And look, when we fixed the battery or reconditioned it, all the terminals are clean, and look at our block voltages, between 14 and 15.1 at the max, okay? We have a balanced battery now. All right, here's another problem that came in, what I call the triangle of doom up here, and you have the explanation point. You got problems on this vehicle. And here were a bunch of codes from a malfunction and a energy balance thing, a whole bunch of stuff. Well, look what happened. This was from a Toyota dealer in the Bronx. One of my students bought this vehicle when they couldn't get it working. Well, apparently someone in their department cleaned the vehicle, and when they cleaned the vehicle, you see what all this is? That's water. That's rust. And it not only burned, this is the converter, the inverter's on the other side, totally burnt out. And here during the class, we took this down. You see the windings are burnt. This vehicle, rather than being all copper like that, it's shorted out. Never, ever use a hose or a pressure washer or any type of cleaner on these vehicles. You would have to make sure the car's been depowered down for a while. And then what you would need to do is clean it dry. You do not use any chemicals or anything on it, but any leaks are not good. All right, here, let's look at Priuses. Here's an update where we have two 600 capacitors here and one 750. So rather than three 450s, you have two 600s and one 750. Here's where we would remove stuff to use our meg ohmmeter, the MG1, MG2, and we got our resistor grid that drains stuff down. And here's a good picture of it. Look how small that gasket is. And here's our little breather vent, so nothing goes ba-boom inside. 3 wires here coming out. These small wires are for the 201 volt AC compressor. Now, not only air conditioning compressor, AC voltage compressor. 2 wires coming out would be DC voltage, which means you got an inverter inside the air conditioning compressor. That'll set you back about $3,200 our cost as shop owner. It's good to look at eye candy. Eye candy here, when this comes in, always look what their miles per gallon is. If someone is driving a Prius and they're getting 42 miles a gallon, what, they got rocks in their head? Why in the world would you want a hybrid vehicle or an electric vehicle if you're getting poor mileage? The reason why they're getting poor mileage is they probably got VD at that battery or a battery problem, or maybe a motor generator problem coming on. They need to take a look at that very carefully. The brake system on a Gen 2 Prius, no power booster. You're going to need to use Toyota TechStream. The factory software, again, with your J2534 in Opus TrueTech box would be the way to go. Here, the weak link, we're looking at a pump. This pump right here, we're into the fuse. We're looking to see if our circulated coolant pump for the electronics. This is not for anything else other than the inverter, the converter, and the electric motor, or motors, I should say. If that pump fails, there's no warning on Gen 1 or Gen 2. Gen 3, they got smart. They followed what Ford did, and they warned the customer. Okay. Here, they also tell you their ND11 oil is the only oil that you can put in this car. This is a non-PAG oil. No PAG. An alkaline will wreak havoc on this car. So here you can see inside some of the compressors. We do this in a class here. Here's your UVW. You could tell this had a lot of dye in it, and it's a squirrel type compressor. Okay. It is very, very efficient. There is no clutch on this one. And by the way, there's the rotor, there's the stator in there. And by the way, that has some heavy magnetism, never mind the big motor itself. Okay. Up right here, it looks like a clutch disc. No clutch disc. This is a vibration damper. Okay. Well, we've done quite a few of these. These things used to be like $300 to $400. They're now over $1,100. Look what happened to this one. Broke all apart, ruined the motor generator on this car. Okay. This was a late model, I think a 2017 or so Prius. Gen 3 Prius here in the back. The Gen 2 had 12 volt capacitors. That was, remember I said no power booster? Well, these guys went back to a power booster, and this is why you got an RTFI. This is a warning when you go to work on this brake system. When the battery is connected, even if the power switch is off, the brake control system activates when the brake pad is depressed or the door courtesy switch is turned on, meaning open and closing the doors. Therefore, during brake servicing of the brake system components, do not depress the brake pedal or open and close the doors. Well, if you don't know that, and it tells you to use the Toyota TechStream, if you don't know that, you're going to run into a huge problem. And underneath, rather than a coolant bottle that was under the left front headlight, this can hold antifreeze warm, they say, for about 4 to 6 days. Now, it is not for anything else other than emissions. Gen 1 had like a heat riser setup with a TVS, thermostatic vacuum type switch on there, or sometimes called PVS, ported vacuum switch. Here they use the thermos bottle, so when the engine starts up, they can get that engine in a warm mode that'll break down HC and CO, okay, rather than cold start problems. They went away from a glass mat battery. They went to a regular lead acid battery on Generation 4 Priuses. Everything is a lot smaller. When I was at SAE, I took this picture. I have other cars that came in with it, but I left this in there because it's a perfect picture of the motor, the inverter, the converter, and a battery that is a regular lead acid battery. Rules from SAE, Society of Automotive Engineers: any battery that is inside the vehicle, including the trunk area, cannot be a venting lead acid battery. It would have to be a glass mat, an AGM battery, or a battery that is totally sealed, a spiral glass mat. Here was a Camry that came in with a problem, checked hybrid system. You see it was in an accident. And when you see something like this, high voltage system, circuit high. When you see circuit high, I want you at the end, remind me to ask the question. I would like an answer. What does circuit high mean, whether it's on a high voltage vehicle or whether it's on anything else? That is something to know here, okay? When we fixed it, no more light is on. Now, I love this here. Never assume that the Camry hybrid is shut off simply because it's silent. This goes for all their cars. Always observe the instrument cluster for ready indicator, the status to verify whether the vehicle is on or shut off. The vehicle is shut off when the ready indicator is off. Very important, courtesy of Toyota Motor Company. Let's look at some Ford stuff here. Under the hood of the vehicle, you have 2 coolant tanks. Special antifreeze has to go in there with deionized water. You have the converter separately, then the inverter that you'll see a picture of soon. You got a simple assist and charge setup here. Here is that battery. The battery is 300 plus volts. This thing is $12,000 to $15,000. And you see what a trunk lid is? A 15-mile-an-hour hit would ruin this battery, okay? And by the time they were totaling these vehicles at one time, Ford bit the bullet and was giving batteries out for about $3 grand. Somewhere where they make some money on a case, as long as the batteries were not destroyed. Okay. Here is under where the air filter would sit. These are all electronics. These are not vacuum hoses. These are all wires. So all those little computer chips, more power than the lunar landing in 1969, July 20th, 1969 on the moon. Here we have motor generator 1, pretty big. There's our stator windings in a delta or a star pattern as it's wound. And here's motor generator 2 and its stator, okay? It's rotor and stator. Here we're testing the pump, that coolant pump, the inverter pump. We got a good looking pump here. And when you see this, you see that? Stop safely now. Bill Ford took over Ford Motor Company for a while. He said to his guys, I see all the problems Toyota's having. I do not want to have that problem. Why? Inverter pumps fail. These are inverter, converter, and motor generator pumps that I talked about earlier. You've seen the waveforms on. This was an updated pump that Ford put on there, a better pump with less problems. Now let's take a look at a Ford hybrid that's shut down. You have a P0AA6-60, high voltage battery system interlock fault, isolation fault, excuse me. Isolation fault is your worst freaking nightmare. This is the stuff that'll eat your lunch. Your scan tool is not going to help you. It's just going to say you have it. You're going to need to know how to use a megometer. You're going to need to know what to do and how to find it. And as you can see here, it tells me I have a BCM count. My battery pack is good. My state of charge, SOC, is 81% on the battery. And it tells me my R leak is 121,000 ohms. Notice that line right there. After I fix this vehicle, I got no codes up top. My battery pack is 84%. I'm 302 ohms. We can see that right there. Low resistance that we had before with 100 is high current flow, okay? So you don't want high current flow. Here is the new Ford Explorer, and the new Ford Explorer that they're using for police cruisers in the city. They got a battery, but I like the way they did this battery. Not only is it cooled and everything here, you got hoses going in, but I like that it doesn't go to the end of the lifting points. The battery is safe, just like a Chevy Volt. It's safe. Some of the other vehicles we're going to talk about in a minute, you better have someone that knows what they're doing, okay? You got an expansion tank here, a control module, a special radiator, a high voltage battery, and that water pump, just like you just seen on I Told You Stop Safely Now and on the other setup. So here, this is a shared 10-speed that GM and Ford actually utilize together. And when you look at this electric drive, the engine is off and the electric motor drives the transmission, providing torque to the wheels, meeting the driver's demand. The engine disconnect clutch is disengaged during the electric drive mode. So you see here I have the 2 arrows. That is one motor generator. Oh, who used that? Honda. So it's still relevant because this is brand new as of like 2 years ago. Okay. So they went away from having 2 motor generators to 1 motor generator that can do the job. Less weight, less problems, less motors, until we go to 1 motor per wheel. Okay. Here is their shutoff switch. You don't need gloves anymore, courtesy of Ford Motor Company there and ALLDATA. And here, the picture I took right here, I'm going to tell you a little warning when you push this down and pull that out. Well, it went, I don't see it anymore. And when you say you can't see it from where you live, well, that's an important part to be in there. That's a lock that will prevent. Now, they're going to tell you to use an Allen key. Once you open this up, there's a little piece that comes out, and they want you to kind of lock that out. Europeans, we use a little luggage lock, okay? You're going to see one on a vehicle coming up in a few minutes here on a BMW that is a big lock through there, but that's for a reason. We did that because they made a mistake. That is not a high voltage connection. That is a low voltage connection, but they made it orange. Shouldn't be orange unless it's high voltage, 60 volts and higher. So here is a BMW N6344 active hybrid, very expensive car, like $160 above. Hybrid system malfunction. And it tells you here, even on the eye candy, make a long story short, this is ISTA. We use the factory tool on this vehicle. And I want you to read this here real carefully. I'm going to play the blow-up doll. All European car manufacturers will do this, okay? And this says this vehicle is an alternate drive. Work on vehicles with alternate drives may only be executed by a specifically qualified technician. Otherwise, there is a danger of injury to BMW Group. Meaning, and everyone does this. Otis does this. When I'm on here, I connect to the cloud. So when they're telling me, do I have the proper training? And I click that. They ask you like a couple of times. That means if you kill yourself, well, you're an idiot, right? You didn't have the right training. This is where a shop owner has to know what PPE stuff and what he needs to do for his technicians to keep the liability at a minimum, okay? Now, this car here has a laser welded type battery. You cannot open this battery up at all. It uses air conditioning, so refrigerant, 134A. It uses engine coolant. The coolant system has to be bled. It cannot use anything other than special deionized water. Here is the shutoff, a low pressure, low voltage shutoff. It's just a jumper like you've seen on the other ones. Okay. Look at an extended range. Here was the first Chevy Volt. When I had my first 2011, this came from the zone office. They loaned me this car when they had my car. And I want to take notice right here that we are on a J1772 plug outlet here. And notice the cord is orange. Well, it shouldn't be orange. It's not high voltage. This is a 110, 120 level 1 charger, okay? So this is a electric motor with an ICE. You can see the wires here, UVW, 2 motor generators, and you see all that wiring? Later on, they did away with all that. That's called voltage drop. They did direct connections. And when we use the factory software, this is also important to cover my butt. And all of these screenshots and stuff, we do this. We just did a couple of, we had an electric experimental vehicle, 2013 Ford Focus, full electric. I've never seen one. It was the first one. Okay. We take all those screenshots and we put it into AutoLeap. Then we could text it to the customer. We keep it under the customer's name. You can email it to them. You get a whole bunch of good information there. So good shop management stuff, and they're not paying me to say this, okay? This is what we do here. If you come by to my shop, this is what we do. AutoLeap is a great asset to have in the shop working with us. So you want to say here, this test verifies certain DTCs associated with high voltage safety successfully ran and passed. And engine maintenance is one of the things that has to be done on the car. So the engine has to run. Well, I get 158 miles per gallon average. Now, I live here in New York. My buddy Scott Brown, you may have heard of Scott from IATN, diag.net. Scott Brown, he basically drove my 2011 one, and back on that one, I think I got 127 miles a gallon. He was like, this is a great car. He bought one. His 2013, okay, same model that I have, he gets 300 miles a gallon. Well, when you live in that crazy California, you know, the weather's a lot better than crappy New York over here, right? It's steady, and his charger's all over the place. So he does a way better job on this vehicle. So the engine has to run here because you could have an issue. So here's the Gen 2. They made the battery pack from 600 down to 405. They have 192 prismatic cells rather than a 6-foot battery, 5.5. A bigger motor, 1.5 liter with some, you know, VVT stuff on it, some GDI, a better system that these, I know a few people that have them, they're getting about 175 miles a gallon, okay? And that's just normal driving. I don't drive like a wuss, you know what I'm saying? I drive a vehicle like you should drive a vehicle. Now let's get into electric. So here in New York City, bought a whole bunch of them, not only for MTA, but for police cars. These things are pretty damn good. Haven't owned one. Here's mine over here, okay? This thing goes pretty decent, but there's something called range anxiety. This is for real. Look back about 6 months ago, 2 ladies that write for the Wall Street Journal. They were all tickled pink every week. We're going to take this trip from New Orleans to Chicago, Illinois. Okay, great. Well, when they did it, they couldn't eat dinner some nights. They were online trying to charge their vehicle up. The weight, and you only get 80% of a charge. You're on a level 3 charger. These are things you need to know. You're going to need to get a charger. One of my shops that we do work for, they asked me, hey, we got a car here and it has no juice in the battery. Do you have a charger we can borrow? Oh yeah, come unbolt it from my building and put it there. You know what I'm saying? So you're going to need to invest in a charger as well. And we can see under the hood of the car is all electric. There is nothing. You still got antifreeze in the vehicle. That is to cool the electronics. Here is the J1772. This is just like any charger except Tesla, okay? And by the way, Elon Musk opened up all his chargers, the greatest charging network in the country. He is making Biden happy and getting Biden money. And basically, he is allowing anyone to use his chargers. Now, I could tell you, most of the time when I pass the chargers, people are charging. So now if I wanted to go there with my Chevy Volt and I buy a connector, well, guess what? I could go and charge it up. This is for the DC. You see the little flip down door right there? There's level 1, 2, and 3. Level 1 is what comes with the car, 110, 120. That will take quite a bit of time to charge it up. That's a slow charge. Level 2, 220, 240. That's probably the best. This is what I have at my house. You should have in your shop. Level 3 is all DC, high voltage, not good for the battery. Only could charge up 80% of the charge. Usually within 45 minutes is your max charging time. All right, a few other things here, the battery pack.
Sorry to interrupt, G. We have a few minutes left. I wanted to make sure that we get to our Q&A questions. We had a few that came in, so I want to go through those real quick. Okay, so Shane asked, where can the gloves and rescue hook be purchased? Any suggestions on the best places?
Yes, so Highline is one of them. There are many companies out there that sell high voltage gloves, covers, and the glove dust and the pole. So you can look it up for anything. High voltage Granges may even sell some. Be careful on the dates. Everything is date stamped. A glove could be put into service for 1 year. When the pandemic hit, I basically had a lot of new gloves, and guess what? We couldn't do any classes. So all those gloves that were never opened all had to get back and be recertified. In your shop, once they're in use, you only have 6 months before they have to be retested.
Got it. Awesome. And then Manny asked, what did you use to clean the connections?
That's a whole process, talking about the bus bars. That is vinegar, salt, and a special way of doing it.
Awesome. And then I think Dylan was responding to with a potential answer to one of the questions you asked to bring up. You previously asked to bring up the question, what does circuit high mean? And
Yes.
Dylan asked you whether it means a component has shorted.
Okay, good try, Dylan. Anytime you see circuit high, 9 out of 10 times it's an open circuit or a short to power. Circuit low would be a short to ground is the most common with that, but circuit high is usually an open circuit. And it doesn't matter if it's a high voltage vehicle or you're working on a regular vehicle. That is what you need to know there. And thanks for the questions. I appreciate it.
Awesome. Yeah, thank you very much, G. I think we do need to wrap up there, but thank you everyone for joining this session. Really appreciate your time today, and hope you enjoy the rest of Amplify today.
Yep. And if you're interested in more stuff, you can always email me at gt@attstraining.com. And if you're interested in the hybrid EV class, we got one coming up right there in April 28th, 29th, 30th, the 3-day class. Thank you for having me, AutoLeap, and thank all of you for being on. Have a great day.
Great. Thank you, everyone.